Hi everyone! For the rest of this module, we're going to develop an I/O API with error handling, retry logic, and asynchronous execution. Now you might wonder why we implement this API ourselves instead of using an existing open source library such as Ch05, Monix, or Ch05. We do this mostly as a teaching exercise. I believe that the best way to learn and remember a concept is to implement it yourself. The goal is not to create a fully fledged open source library, but just to implement enough of the I/O API in order to understand the most important ideas behind it. We can't do this by studying the code of Monix or Ch05 because these libraries are extremely complex. Not only do they support advanced features such as resource management and cancellation, but they also focus on performance. As a result, their code is very difficult to understand. In other words, Monix and Ch05 are great libraries to use in our job, but they are awful as teaching material. Okay, so first let's open the file io.scala in the package exercises.action.fp. As we saw in the previous lecture, I/O is a trait with a single abstract method, unsafe_run, which triggers the execution of the action. The trait has many other methods that we will implement today and over the next few videos. At the bottom of the file, you will find the apply methods. So this is the constructor of the I/O class, and it takes a by-name parameter, which is evaluated by unsafe_run on every call. I also implemented a few tests for I/O in the file iotest.scala. So let's open it. The first test checked the behavior of apply using the same techniques that we saw in the lecture on evaluation. We use a mutating variable and an action that modifies it, and observe when the action is executed. First we check that apply is lazy, meaning that after the I/O is created, the code inside the action has not been executed. That's why counter is still equal to 0. Then we check that after each call to unsafe_run, the entire action is re-evaluated. So now counter is equal to 1 and then 2. Now our goal is to develop a powerful API for I/O, but it's a bit unrealistic to do this without a concrete use case. So I propose we go once more through the example of creating a user from the console. Let's open the file a user creation service inside of this console package. So as you can see, I already implemented all the logic and all the tests for it, since we already done it in the imperative package. But the code currently looks really horrible. For example, if we look at the code of readName, currently it starts with I/O followed by curly brackets, so this is the constructor of I/O. And within the method, we need to call unsafe_run on both writeLine and readLine, since now both of these methods return an I/O. So I can show you this is a new console interface. Both methods now return an I/O in this version. If we compare this code with the imperative version of readName, the version with I/O is much more complex and doesn't have any visible benefit. Now, this is completely normal because the I/O API is currently very limited. We only have the apply method to create an I/O and unsafe_run to execute it. But we don't have any other methods to combine I/Os together. That's what we're going to do now, and hopefully by the end of this lesson, the code with I/O will be much more readable. Okay, so the first exercise for today is to implement the method and then on the I/O trait. So let's open it. And then run the current I/O, the one where and then is defined. Then discard the result, and finally run the second I/O passed as parameters. For example, if we have the action io_println fetching user and the action db.getUser1234, which return an I/O of user, then we can combine these two actions using and then. When we run this combine action, it will first print the message and then fetch the user from the database and returns it. I also wrote a few tests in the iotest.scala. So let's open it. So as you can see, currently this test is ignored. And it used this mutating variable techniques that we have seen before. So first we have a counter set to 0, and we see that the first action increment this counter by 1, the second action multiply counter by 2. What we do here is that we say first and then second, so we combine these two actions together, and we verify that just after we have done this, nothing has been executed. The entire I/O API is completely lazy. We are just building up complex actions from simpler ones. The code should only be executed when we call unsafe run. So when we call unsafe run, it should first increment by 1 and then multiply by 2. So this test verifies that both actions are executed and in the correct order. Cool, so now it's your turn to implement and then. Please pause the video and give it a shot. Okay, so let's first enable the test for and then. So like this, we can run it at the moment. It should fail because the method hasn't been implemented. Yes, it does. Cool. So now, how are we going to implement it? Because and then return an I/O, we don't really have choice at the moment. We need to call the apply method. We need to call the constructor of I/O. Now, here what we want to do is first run the current action. So we can say unsafe run, meaning that we want to call this method here. This is going to give us an A. So this is going to give us an A. And then we want to call the second method other and call also unsafe run on this. Now this first method, this first action, we are going to discard the result. So we can completely remove it like this. This first result is completely useless. So let's check if the test passes. Yes, it does. And for example, if we were going to swap the order, if we were going to swap the order, we can see that the test will not even compile because the second result, this unsafe run returns an A while we expect an other. One quick refactoring that I would like to show you is that I actually prefer to write this method like this. So I don't know if if you come from Java, you're probably familiar with this or other object-oriented language. This references the current object where we are. We don't have to use this in general, but I find this slightly more readable in this particular case because it really says I want to call unsafe run from this object and then unsafe run from the other object. So it creates some sort of symmetry, but you don't have to do this. Okay, so now that we have implemented and then, could you go to user creation service and refactor rename using and then? So please pause the video and try to refactor this code and don't forget to run the test for it. Cool, so what we're going to do is that we're going to remove this io.apply. We don't want to create a new IO from scratch. We want to combine these two IOs together. We're going to remove this unsafe run. And basically, we want to call and then between these two methods, between these two IOs. So we'll say like this. So we say console write line. We want to first write this line, and then we want to read a line. So I think it's quite readable. Let's run the test. So this is the test suite for user creation service. Everything passes. Cool. Now I would like to show you some quick refactorings we could do here to make it slightly more readable. Because within this class, we're going to always call a lot of console write line, console read line. So it could be nice to actually just use write line, read line instead of console dot. We know where does it come from. It must come from the console over there. So in Scala, we can import all the methods inside console using console underscore. Or we could be a bit more precise and say like console read line, console write line. So it's really up to you. I think in this case it's quite nice because it's going to make our code much more readable this way. So if you want this import is exactly the same as using an import on top of the file, except that it is local to the class where we are. Cool, so before we move on to the next question, I would like to show you an alias for and then. So if you look at the code of Monix, Zio, Ch05, there is a popular symbolic operator, a symbolic alias for and then. It is this asterisk and arrow pointing to the right. Some people call it the ice cream operator because it kind of looks like an ice cream cone pointing to the right. And let's have a look at how we would use it in practice. So it will be like that. So we can replace and then by this operator. Now, it doesn't save too much code, but it's quite convenient in the sense that, it's a good reminder which value do we keep. Here we want to keep the value from readline, so that's why the cone is toward the right. In these other libraries, there is also an ice cream pointing to the left, and in this case it will mean we want to execute these two actions from left to right, but we want to keep the result of the first action. So I just wanted to show you this alias because it is quite common and you will see it in practice. But I would recommend you that you use and then at the beginning. Now let's have a look at read date of birth retry. So similarly to read name, the code is quite complex right now because it executes three internal actions one after another. It does read line, write line, read line, and here it parses the date of birth. So could you please pause the video and try to refactor read date of birth so that we use and then, we combine each action using and then. Okay, so let's try. So similarly to last time, we're going to remove the IO constructor. We're going to remove the unsafe run. Remove this. And basically we want to use and then between each IO. So we'll say and then like this. We can also remove all the console, so we can say just write line, read line, and so on. So as you can see, the problem here is that in the last action in this block, we need to have access to line. Line is the result of read line. But and then doesn't propagate the result from the previous action. When we implemented and then, we run the first action, but we completely discard its result. So in a sense, and then is not suitable whenever you need the result of the previous action to execute the next action, which we often do. So here, let's just put triple question mark here just to make the compiler happy for now. And what we're going to do is that we're going to have a look at the method map on the IO trait. So it's defined here. So map seems to be exactly the method we need because it gives us access to the content of the current IO. So please pause the video and try to implement map. And once you're done, go back to user creation service and try to use map in the implementation of read date of birth. So please pause the video and give it a try. Okay, so first I propose to go to IO test and enable the test for map. And let's have a look at what it does. It increments counter by 1. Then we call map on this IO we just created and return a constant. So in fact, the callback function we use is not really relevant. Really the only thing we really need to test here is that after you call map on an action, we want to verify that the IO is still lazy. Nothing has been executed. And then we want to check that after we run the action, the counter has been incremented. Okay, so now if we go back here, how are we going to implement it? Well, first, we want to run the current action. So we want to say unsafe run. This is going to give us an A. So we can say val result, and this is of type A. Then now that we have an A, we can pass it to callback, which will give us a next, exactly what we want. So let's run the test. Cool, it works. Cool, so now let's go to user creation service and let's try to use it. So map, the nice thing about map is that now it gives us access to whatever is produced by readline. So now we do have access to the line the user types in the console, and then we can pass it to parse date of birth. Now, as you can see, it doesn't compile, and the error message is not extremely clear. It says that it expected a local date while we got an IO of local date. This is because, if you want, here we had an IO of string, and when we map it with this, which is an IO of local date. So really, the result of this expression is an IO of local date. so which doesn't really make sense. It doesn't, you almost never want to have an IO of something. So one way to fix this problem is to implement a method like flatten. Like we have flatten on list. If you have a list of something, you can flatten everything together. We could do this for IO. But a better alternative is to use the method flatMap. So let's have a look. It's defined just below map. So flatMap is like map, except that the callback function returns an IO of next. This means that flatMap allows us to combine two actions together, just like and then, except that with flatMap, we can use the result of the first action to determine the second action. For example, we could fetch a user from a database and then send them an email using the data that, using the email address that we found in the database. Okay, so first let's implement flatMap, and then we'll use it to refactor read date of birth. And don't forget to enable the test. Okay, so to implement flatMap, we see that we need to get an IO of next at the end, and one way to get an IO of next is just to call callback. So if you want, if we pass an A to callback, we get back the right thing. So what we could do is, let's say, call unsafe run. This will give us back a result exactly like before. And then we can call callback with this result. Yeah? So let's enable the test to see if it works. No, it doesn't. So if you look at it, what does it say? It says that we expected 0, but we got 1 at this particular line. So as you can see, the test, what was it supposed to do? It has two actions exactly like and then, one that increments by 1, one that multiplies by 2. And what happened is that just after we call flatMap, counter is equal to 1. So it seems that after we call flatMap, the first action has been executed, but not yet the second one. And it kind of makes sense because here we do call unsafe run, but we are not within an IO constructor. So you see here we call unsafe run within an IO constructor, so everything was lazy, everything was delayed. But we didn't do this here. So if you want, this implementation of flatMap broke laziness. So it's a bit subtle to see it, but at least we can see that our tests were able to detect it. So to fix it should be relatively straightforward. We can use the IO constructor, but now callback returns an IO of next, and we are within an IO. So we are a bit the same problem that we had before. This is not an IO of next, it's an IO of next. Even though, so you see, it found an IO of next while it required a next. So what we need to do here is actually run this second action. So it may be a bit confusing as you look at the code like this, but if you think about it, we don't really have much choice. First, we need to execute the current action, then we call callback that gives us a second action, and we need to execute the second action. So let's run the test to see if we fixed it. Yes, it works. Okay, so now let's go back to user creation service, and let's try to use it in our code. So this was before, what was it? It was parse date of birth. So we can say parse date of birth with line, and hopefully this should work. So let's run the test. Oh, actually I didn't run the correct one. That's always the risk with this sort of thing. So let me run it from here. Yes, all good. So as you can see, and then is convenient when we want to compose actions that don't depend on one another. So for example, if the first action don't impact the second action, at least we don't need the result of the first action in the computation of the second one. While flatMap allows this extra power of accessing the result of the previous action in the computation of the next one. So these two methods are quite convenient. Now let's try to refactor read subscribe to mailing list and read user using and then and flatMap to make basically this code more readable. So please pause the video and give it a shot. Okay, so for read subscribe to mailing list, it's going to be very, very similar to read date of birth. we just remove the unsafe run, we remove the IO constructor, and we're going to use and then between the first and second action because we don't really care about the result from right line. And then we'll use flat map between the first two actions and the third one. So in fact, we could even use this syntax, or we can even use it like this as a lambda, because here we define line and we pass it straight away, but we can also make it, don't even give it a name and pass it automatically. We can also simplify slightly the logic, removing this console. Okay, so now it's quite nicer to read, like one line, describe one action. Now let's refactor read user. So I'm not especially good with IDEs, so I probably don't know all the shortcuts that you know. There is probably a much better ways to do this than what I use. But basically, we want to remove all this unsafe run. Then after each read name, we want to use flat map with curly brackets. And this, within this flat map, we have access to name. So if you want, instead of having val name, read name, we have read name, flat map, name. So it kind of swap the order of the action and the result. So within the callback of read name, what do we want to do? We want to read the date of birth. This will give us access to the date of birth. And then what do we want to do within the callback of read date of birth? We want to read the subscribe to mailing list. So as you can see, it starts to be painful already to have like several levels of callbacks. Then it keeps getting worse because now we're going to call clock.now flat map to give us access to the timestamp. Now, this variable, we can move the code straight away like this. That's completely fine. Now, we have this action here, and then we want to return user. Actually, here, yeah, that's not correct. So you see, we have right line. We want to execute it. So the only way to execute it is to combine it with a flat map or a map. So actually, what we want to do here is to call map and discard the result because we don't really care about the result from right line, and return user at the end. We can slightly refactor this. We don't need clock. We can do it this way. So really, in summary, we can see that and then and flat map help us to simplify the code for read name, read date of birth, read subscribe to mailing list. However, it didn't really work out for read user. It has really made the code more complex. This is because read user needs to combine many actions together, which means invoking many flat maps one after another. And as you can see, flat maps add a level of nesting and indentation, so it quickly becomes difficult to read and understand. So I propose we take a break now, and the next video we'll have a look at for comprehension, which is a fantastic feature in Scala that will drastically simplify the code of read user. So have a good day, everyone.